Hello, everyone. In our last video, we talked about concurrent lines and that the point where the perpendicular bisectors of a triangle meet is called the circumcenter. Today, we're going to talk about the incenter. The incenter of a triangle is the point of concurrency for the angle bisectors. The angle bisectors of a triangle will always intersect at one point, which is called the incenter. So in this triangle over here, P is the incenter because it's where the angle bisectors meet. The bisectors of the angles of a triangle are concurrent at a point equidistant from the sides. This point is called the incenter. But what that means in our triangle up here, where P is, that means that DP, PE, and PF are all equidistant. So now if we look at our graph that we have here, it says, do you think there is a circle associated with the incenter? Remember, our circumcenter was the center of the circumscribed circle. Our incenter is the center of our inscribed circle. Inscribed circle is inside the circle. So now if we look at this problem, in the diagram below, P is the incenter of triangle XYZ. The length of PK, find the length of PK and the angle measure XZK. Okay, so I'm looking for PK. So to find PK, what I need to know is I don't have anything around PK, but I do know that PK is equal to PJ. And if I look here at PJ, right here, I have a right triangle. And I know that's a right triangle because this side's a right angle, so this side's a right angle. And I know two sides of that right triangle. Whenever I have a right triangle and a missing side, I can use the Pythagorean theorem. A squared plus B squared equals C squared. And the missing side is a leg, so I'm going to call it A. And my other leg is the other part that makes a right angle, so that's 12 squared, equals the hypotenuse, which is the side across from the right angle, 20 squared. So I solve that, A squared plus 144 equals 400. I subtract 144 from each side. And I get A squared equals 256. I then take square root of both sides, and the square root of 256 is 16. So A equals 16, which is how long PK is. Because PK, PJ, and PL are all equal. Now the question is, what is the angle measure of XZK? So if I look at XZK, actually XZK, I'm looking for this angle measure right here. So when I look at this triangle, this red triangle, I know that down here at K I have a right angle because that side's a right angle. And I know that this angle is 31. Actually, I don't want to look at that right triangle. Sorry, because I don't know necessarily that's a straight line. I want to look at the big triangle. Sorry, big triangle. And I know that up here, this side's 31, which means this side's also 31 because the incenter is formed by angle bisectors. Over here at Y, this side's 27, so this side's 27. So what I'm going to do is I'm going to find all of Z. So I know that triangles add up to be 180. So all of X is 62. because 31 plus 31. All of y is 54, because 27 plus 27 is 54, plus z equals 180. Triangles add up to be 180, so it's 62 plus 54 is 116, plus z equals 180. I subtract 116 from both sides. And I get 64z. Now z is 2 of the angles I want. So I'm going to actually divide 64 by 2, and I get 32. So the answer to xzk is 32. So that's the end of our video. If you have any questions, please bring them to class tomorrow.